Welcome back, rock stars. Welcome to day 8 of the annual Rock, Paper, Scissors Challenge. Second day of the tournament. Hopefully more of you have gotten into the tournament area and it's starting to get interesting. Let's jump over to the agenda. As usual, the HyperDoc is your friend. If you've missed any classes or need to go back and review something, open up the HyperDoc and you will find the information there, including if you haven't started yet, how to start on rock, paper, scissors. Okay. Also, RepeatWinningMove, where we're doing the PSRock challenge, does not have a conversation mode. So if you get stuck and have a question, right? I have office hours Tuesday and Thursday this week. Normally Monday, Wednesday, Thursday. You just have to book that more than 18 hours in advance. Normally these classes run short, and so you can always just hang out after class and ask me then. If neither of those things are going to be soon, don't wait. Send me an email and I will try to answer it as quickly as I can. Okay. As usual, open up today's guided notes and take some notes in there as we're going along. If you do have a printer, it's awesome to print them out so you can just write stuff down. It's easier than switching screens or doing that. Essential questions and objectives are the same. We'll talk about them again as in the last week or so that you guys actually think through them. And let's get into the slides. Okay. So we've figured out how to detect if somebody else is repeating the same move over and over, 2 moves over and over, 3 moves over and over, whether they're giving you your last move back, whether they're trying to beat your last move. Okay. Today we're going to learn a new one. And that is RepeatWinningMove. Okay, so if you look at the throws that are going on here, right, and normally when we do analysis, we're going to skip the first 2 moves. So move in turn 3, right, they threw scissors, right? Now you might say, well, scissors beats paper, so maybe they're trying to beat last move. And then the turn 4, they threw rock. Well, rock doesn't beat rock. Rock ties with rock. Okay, and in the 5th turn, they beat scissors. Yeah, rock beats scissors, but it's also the move that they threw the turn before, and then they threw paper. So what this algorithm is actually doing is they're looking at the previous 2 moves and saying, well, what move won then? Between paper and scissors, scissors win, so I'm going to do scissors. Between rock and scissors, rock wins, so I'm going to do rock. Between scissors and rock, rock wins, so I'm going to do rock. Between paper and rock, paper wins, so I'm going to do paper. Okay, so this is actually kind of a double algorithm. This wins in 2 cases. If the other player, so this is a double algorithm, and by that is if the other player throws the previous winning move, you tie. If the other player throws a different move, you have a 50% chance of winning. So it's not a bad strategy. It's used kind of often in actual rock, paper, scissors tournaments until somebody else figures you're doing it. So how can we detect it, right? There's for your move, there's 3 different choices. For their move, there's 3 different choices, right? The combination of 3 choices and 3 choices, that's how many combinations is that? 3 times 3, that's 9 combinations. It's actually not that hard to check that out, okay? So here's how we would traditionally approach this. Let me move video out of the way, right? So we would just make an in-out table, right? So we want to compare what's the winning move between 2 moves, right? So winning move of move 1 and move 2, we could say of my move and of their move. We actually don't care whose move it was right now. Okay, so move 1, move 2, let's say, so we're going to start with I threw rock. They might throw rock, paper, or scissors. I threw paper. They might throw paper, rock, or scissors. I threw scissors. They might throw scissors, rock, paper. Okay? It doesn't matter what order you put these in, as long as you put them in a way that you can correctly get all 9 combinations. Traditionally, so typically, right, we would have one person do the same move 3 times, and then the next move 3 times, and the last move 3 times, and then the second person do one of each move. Right? And I could have done rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. Here, that might have been easier to count off. We have 9 of them. Then, okay, well, between rock and rock, what wins? That's rock. Between rock and paper, what wins? That's paper. Between rock and scissors, what wins? That's rock. Okay, so we got that part done. Paper and paper, well, paper wins. Paper and rock, paper wins. Paper and scissors, scissors wins. Scissors and scissors, scissors win. Scissors and rock, rock wins. Scissors and paper, scissors win. So this is our input-output table. To me, because I've been coding for so long, this almost looks like an if-else or an if-then table, right? So if move 1 is rock and move 2 is rock, I want to return the winning move of rock, right? So I would just have a code that has 9 of these if lines, and I would fill in the 2 moves from my table, and then I would return that winning move. Okay, there are other ways of doing it. There are shorter ways of doing it. This one is straightforward and easy to understand. So this is a nice function to add in. When could you use this function? Well, you can use it whenever you want. If your detects aren't working, you could certainly use this function. You could use this function all the time if you find your detects aren't helping you at all, and just using this function wins a lot, right? So you could use this whenever you want, right? So it's your choice of when would you call this. Now, the other question is, can you detect it, right? So if you have a function called winning move of move 1 and move 2, could you use it to see if the other person was playing it? I think you can, right? If their last move is equal to, if only I had a function that if I gave it my last move, or my second to last move and their second to last move, what was the winning move of those two, right? Well, maybe I do have a function like that. Maybe I could do this, okay? I'm not going to give you more details. At this point, to get above a 3, you guys need to be able to figure out some patterns and how to detect them on your own. So I'm leaving this mostly blank for you guys to do that, okay? So I've gone over the winning move function, right? How we can kind of conceptualize it as an input-output table, right? If there's a function that's going to take 2 moves and return a third move, well, it's kind of like an input-output table with 2 inputs and 1 output. It's exactly like that. And I can convert an input-output table. If move 1 equals this, if move 2 equals that, return that, right? So it's a little bit long, but I can copy and paste, right? I could copy and paste these 2 lines, and then all I need to do is change the 2 input moves and change the 1 output move. That's pretty fast, right? Copy and paste is your friend in comp sci, as long as you're doing it on code you're allowed to do it on. That is it for today. Super short class. You guys need to get into the tournament, get your stuff running there. Once you join the tournament, send me that email so I can add you to the long report list. This code today, the repeat winning move or beat repeat winning move, is not part of Friday's assignment. It's your choice on using it, when to use it, how to use it, right? So it is part of the final project, but it's not part of Friday's assignment. Cool. So we can detect 6 different sets of moves. We can detect repeat 1, repeat 2, repeat 3. We can detect copycat. We can detect if they're doing beat last move. And now we can detect if they're repeating the winning move from the last round. Okay. And if we can detect them, we can beat them. From here on in, it's just better and better, but you need to get into the tournament and actually debug, look at the long report for the teams that are winning matches versus you and seeing what they're doing. It might be a new pattern. It might be adjusting your own patterns to change which order they're done in to improve your results. Okay, that's it for today. I hope you guys are getting your code ready, getting into the tournament, and having fun. We have 2 more weeks after today on Wednesday, June 10th. That's it for the class. You guys are going to have your presentation and videos done for that day, and we'll have the big challenge tournament and see who's the best in the class. I will talk to you all on Monday. Have a great rest of your week. I hope you have a good weekend, and that's it for now.